Okay, recording started. So let's click on the first lecture, introduction. So what I want to do here is to start to talk about climate change. So during this first conversation, there is no medicine, no connection with very few connection with health problems, injuries, etc. But my purpose is to start discussing about what climate change is. Before I start, let me just ask you a couple of questions. So first of all, where are you from? I'm interested in that. And so can I start with you? Where are you from?
I'm from Turkey, Istanbul.
Okay, perfect. And you?
Milan.
Milan? Monza? Aosta. Okay, great. I'm passionate. I'm passionate about Aosta actually because I like mountains and so very nice. But you stay in Milan, I think. Yeah, of course. Okay, and Monza you're traveling? Yeah, sorry?
I'm from Newton.
From Newton, yeah, you're traveling. Okay. So what is climate change in your opinion? How would you define it? Can I just start a conversation? Just to know, I have a couple of questions for you. So who starts? Who breaks the ice?
It's the progressive rising of the temperature of the Earth and its consequences.
Ice. Okay. Okay. It's not bad. Other ideas?
Probably different changes in the environment with respect to what we knew before.
Different changes in the environment. Okay, this is, I would say, is a good definition for environmental change, not really climate change. And I will show you the official definition of climate change. So, but this is just for me to understand what is your catch of climate change, because I don't want to say obvious things. On the other hand, I don't want to take for granted concepts that in a different perspective maybe not so known. Do you have any idea what is climate change?
I would say any change in climate which is contrary to what happened in the year before. So it can get warmer or colder.
Okay, and let me insist on that. Sorry if I ask other questions. What is your take of climate? What is climate? Because I tell you, it's students usually don't get what is climate.
So I think climate, for example, weather is for a short period of time. It's for like short period of time, and climate is the general trend. So I would say the average of the weather.
Yeah, this is a perfect definition. So we need to distinguish between weather and climate. Weather is day to day values of variables, selected variables like day-to-day temperature. Climate is long-term statistics of the same variable. So when we say that there is a temperature increase as an effect of climate change, we mean long-term average temperature. It's not. So some people say today's too warm, it's climate change. No, if today's too warm, maybe an effect of climate change, but it's not correct to refer to a single day for climate. Usually, the climate scientists, they say that these statistics should be computed on a window that is at least 30 years long, at least. My interpretation is that it's a bit too long. It's already climate in 10 years, but they say at least 30. And I am also curious, do you think that climate change is one of the top challenges for humanity at the global level? Or would you say that there are other challenges which are at least of the same importance? What is your take? Because some students are really convinced that climate change is everything, and other students say, no, it's not really a big problem. Just to know your opinion on that.
I think there may be equally important or perhaps bigger issues,
Mhm.
but I think climate change will show its consequences in the future
Mm.
or maybe in a more evident way.
Would you agree with this or?
Disagree with me, let's try to be.
I think like most of the issues that come to mind that are like massive like issues of the future, such as migrations which have, you know, increased or well, health problems as well, like they all are tied in some way, not maybe not completely, but in some way to climate change. So I would say it's like one of the biggest, if not the biggest problem.
Okay, okay. Do you have anything more to add?
I mean, I agree on the fact that climate change and other issues, for example, like global hunger and poverty, they might influence each other. Like if we're taking, for example, like poverty as under a global point of view, it might be related to climate changes. Some environmental condition might dictate what
Okay,
how the issue can develop.
okay. Yeah, and then I tell you what is my comment, and then the next slides we'll try to find an answer to these questions. Do you have something to add?
I mean, I agree.
Okay, okay. This is a big question. So there is indeed a debate in the scientific community whether climate change is the most compelling issue or whether it's water security more compelling than climate change. They may be related, but you know, one thing is if you say I want to solve the problem of climate change. One other thing is I want to solve the problem of water security. The solutions may be a little bit different because you may decide not to care about climate change, but finding solutions for securing water. And other people say, for instance, a poll that has been made in the European Union, I think 10 years ago, and they asked people to rank the most concerning global threats. And 10 years ago, you know, it was a period that was still, people were very concerned by terrorism. And in fact, terrorism was in the first place. And then there was migration, global migration. And I think climate change, the global economic crisis, because 10 years ago, after you know, the big economic crisis of 2007, 2008, people were really very concerned. And the public debt for most of the states in Europe was really a concern. So the third one, I think, was economic crisis, and the fourth one was climate change. And this is a big issue. And a big question, I mean, and you know that there are the movement of Fridays for Future, they are really striking because they are convinced that politicians don't recognize the urgency of climate change. And okay, another big issue is whether or not climate change is human-induced. And let me say, for sure it's human-induced, but there is also, and we will discuss about this, there is also natural variability of climate. Because we know that we had ice ages and we had also fluctuations in climate. Even after the Roman Empire in Italy, there were fluctuations. And so the big question is, okay, there is for sure a human component, but what is the extent of the human component? So if one had to say it's dominant and it's like 90% of the cause of climate change, or it's 70, 60, 40, and this is another big issue. So let's suppose that it's human-induced. Let's suppose that, and we will discuss about natural variability. But indeed, there is a clear consensus on the fact that it's human-induced. In your opinion, what is the reason why, and I have a slide dedicated to this, what is the reason why we can say that it's human-induced? So what is the motivation? Why scientists say that it's human-induced?
because we can prevent it or at least decrease it by changing our actions.
Uh,
Maybe.
mm,
that would be
mm.
easy.
Okay, I'm not saying anything because I have the reply later in the slide. Or do you have an idea?
Maybe because the changes happen too quickly and
This is,
therefore,
this is a good reply. Okay, a good, I'll tell you later why it's good. Do we have an idea?
Could it be because there was like a sharp change past like the industrialization of the world, which was human made?
Okay, okay. Do you have an idea or you
Yeah.
prefer?
I think these are, I mean, now, there are some things that are happening in nature that were supposed to happen,
Mhm.
but they're happening faster. It's a little bit of this.
Okay, so the pace of the change,
Yes.
as he said, okay. Okay, let's move forward here with the slides. And I think that it is really a good thing that we explore the topic of climate change in order to understand something better, because climate change indeed originates health problems, and health problems that are demanding for solutions. But in order to design solutions or strategies, we need to know the dynamics of climate change, the mechanisms leading to climate change, why climate change is occurring, and how we define change. So how much change? So the temperature is increasing, how much? Okay. And I think this is interesting also for you, because, okay, let me move forward. So first of all, you may have heard about the Great Acceleration. So the Great Acceleration is the increasing trend in various measures of human activities after the Second World War. Actually, this trend started even earlier, after the Industrial Revolution that some of you mentioned. And the Industrial Revolution was around like 1860, 1880. And the Industrial Revolution really changed the way we developed the society. It really changed our socio-economic structure. It changed it for the better, because there is no doubt that our life standards, at least in the Western world, it's improved. For instance, the life expectation is improved, and living conditions have improved. The health care has improved, and in particular, but you know that at the beginning of the 20th century, at the beginning of last century, we had a big war, World War, and then we had a period that was difficult with an economic crisis in 1929 and then a Second World War. So this societal development was, in a way, a little bit slowed down. On the other hand, the wars promoted a real revolution in the technologies. And this is this always happens during wars. So if one wants to find really wants to find a positive side of wars, is that they stimulate the technological development. They stimulate the investment on the technology. And indeed, after the First World War, there was a big improvement. The war stimulated several discoveries, and the Second World War, the same. So basically, after the Industrial Revolution, it was only after the Second World War that people could benefit from a long, peaceful period, at least in the Western world, only in the Western world, I would say, and okay, also in Asia, but with a little bit of a different history, could benefit from a long, peaceful period of peace, and could benefit from this improvement of technology. And so after 1945, starting from 1950, the economy started to develop at the global level. So there was the birth of global economy, of globalization. And this promoted really an acceleration, a great acceleration, as you can read there, of the human activities. Several indicators show a sharp trend. So 2 indicators here. This is human population, and this is temperature increase, by the way. So there are several indicators that show this kind of hockey stick behavior after 1960, more or less, you see there. And it's you can also see the number of cars circulating, several indicators. The great acceleration, any socioeconomic indicator really exploded after 1960. And of course, at the beginning, this was taken like a fortune, something that was really great, really with no negative effects. But actually, starting from the United States, because they developed a little bit earlier, and then in Europe, we started to see the negative sides of this great acceleration, also in terms of health, because people were started to eat more, and the weight of people increased, and obesity became a problem, and pollution. Soon after the Industrial Revolution, people had to struggle with air pollution and related illnesses, and water pollution. Water pollution, people realized that this big development was polluting water. And the first water that we polluted was the water of rivers, because at that time, like 100 years ago, in most of the cities of the world, they were used to release wastewater directly into the rivers or into the sea, because in the past it was not a problem. Indeed, the rivers have a capacity to remove pollution through natural processes. But if the wastes that comes in are really a big amount, then this capacity of self compensation goes down and water becomes polluted. To give you an example, I talked 30 years ago with an elder person who was he fought in the First World War. And then after he came back, he was living along the Po River. His job was to catch goods floating along the Po River to sell them, because he had no other opportunities to work. And he was used to pass the full day along navigating along the Po River with a rudimental boat, and then to catch these floating goods. And then he said, I asked him, but how could you drink? And because they didn't have bottled, they didn't have plastic bottles at that time. And he said, yeah, drinking was not a problem. I drank the water of the Po River. And this is something that today is absolutely impossible. So you understand the rapid increase of pollution. And so sustainability became an issue. And the concept of sustainability indeed was introduced around 1990, but people started to realize the problem already in 1970s, in the 70s of the past centuries. So sustainability, at the beginning, people were not concerned by climate change. And around 1970, they became concerned of water pollution, became concerned of air pollution, but climate change was not a big issue. And it was not a big issue because actually a temperature increase didn't start until 1980. If you see the graph of temperature, okay, there is an increase after 1930, but you see that indeed up to like 1990, it was not a big issue. So people were not much concerned. Okay, let's move forward with the next one. So, but then around 1990, people noticed that there was a huge air pollution. At that time, people were much concerned about the ozone hole. I hope you understand my English, and other environmental problems. And then suddenly, acid rain was another concern in the 80s of the past century. Then these concerns turned out to be not real concerns. And around 1990, people started to notice that indeed global temperature was increasing. And they referred to the greenhouse gas theory, which was introduced much earlier. The greenhouse gas theory basically says that if you pollute the atmosphere, and in particular, if the CO2 concentration in the atmosphere increases, then there is a greenhouse effect, which means that that the heat that goes from the Earth to the atmosphere is trapped, thus causing an increase of temperature. So they postulated that this increase of temperature starting from the 90s, about 30 years ago, was caused by the increasing CO2 concentration. Because we noticed, I don't have a graph of heat ready to be shown, but if you look at the CO2 concentration in the atmosphere, the graph is all in all similar to the graph of temperature. You can really see that they are coupled. When there is an increase in CO2 concentration, there is an increase in temperature. So this evidence supported the interpretation of the greenhouse gas theory. Okay, good. Now, let's see here. Here, this is an open page. You can play this game by yourself. So what is climate change? And here you see several answers. And of course, after what we discussed first, we would select the second one. Climate change is a long-term shift in weather patterns. Okay, so long-term means a long-term average. Okay. Now, the difference between weather and climate. Okay, so what should we put here? Before refers to the day-to-day state of the atmosphere. Of course, I would put here weather. Okay. And now let's see here. Describes of a place over a period of time, often 30 years. Okay, climate describes the weather of a place. Okay, good. Think about it this way. Climate is something that can be expected to happen in general, like a cold winter season, whereas weather is what a person might experience in any given day, like a snowstorm in January or a sunny day in July. So if you get a snowstorm in August in mountains, it happens. We cannot say this is an effect of climate change. And it is not a correct way. We should say this is an extreme weather event. And if you get like a warm October, like this one, we shouldn't say this is climate change. It's a warm October, it's still weather, because of course, it may be part of climate change, but not necessarily. And this is something that is to be distinguished, because what we are interested in understanding is the long-term change, something that is changing for a long time. You understand, if we knew that this warming is temporary, will last about until 2030, and then goes back, and then reverts, it would be less concerning. We are interested when you hear about climate prediction, they say 2050. Like the European Green Deal has targets for 2050. And it is because they want to look 30 years, at least 30 years ahead. And they, in fact, say 2050, 2100. Okay. Now, change and variability. This is extremely important. Maybe that you already know this, because, I mean, the difference is clear. The difference is clear. But on the other hand, we have to be rigorous in understanding what is variability, what is change. And variability is something that goes up and down, like a normal effect of a process, climate, that is not constant. Strictly speaking, we should say not stationary. So if it is not constant, it means that you can experience one year that is hot and another year that is cold. And you can experience droughts that last for 10 years. Like, for instance, in Australia, from 2000 to 2010, they had a drought that lasted 10 years. And with the drought, I mean 30% less annual rainfall. It means that the amount of water that they got from rainfall in a year was 30% less for 10 years. So they thought that something was changing forever. After 2010, they didn't have any drought after 2017. So it means that climate is subjected to up and downs. And if this cycle up and down doesn't last for a long time, so if the increasing trend doesn't last for a long time, we say it's an expression of variability. Change is a long-term shift. Variability is a short-term shift, something that reverts back. And given that we talk about processes that are extremely variable, think of rainfall. Rainfall is varying a lot in space and time. It's not like temperature. Temperature is smooth. It's a smoothly varying measure. It means that if you take temperature here and you take temperature in Monza, you take temperature in any place of the Padana Plain, there are not big changes in a day. Not big changes in space, not big changes in a day. So it means that the spatio-temporal changes are smooth, are not very pronounced. Rainfall during summer, you may just drive and you get a big storm. After 100 meters, you get the sun. And rainfall in time, it may last 5 minutes, big storm. So these variables are really varying a lot. So distinguishing between change and variability, it's not easy. If you look at this graph, animated graph, there is the global, let's say, it's annual temperature in North America and tropical America. And it's expressed in terms of anomaly, which means that the zero is the value, the average value during the period 1850-2020. So zero is the average during this period. And then you see that there is an increasing trend. And try to see the magnitude of this change. So if we start from 1850, you see that for tropical America, it's less than 1 degree, the change in temperature. And the same for Northern America. You see that if you average out the up and downs, it's about 1 degree. So this is the order of magnitude of temperature increase from the pre-industrial period, 1 degree. So keep it in mind, because there are some media who say +5, +5 is absolutely not realistic. This is an average over a large continent. At the local level, you may find like increases that are greater than 1 degree. For instance, in the Alps, for reasons that we don't know, the increase has been about 2 degrees. So 2 degrees is still something that it's realistic. +5 is not realistic. And you may have heard that the target of the Paris Agreement is to contain the increase of temperature within +1.5. This is because now we are at about, at the global level, +1.1, and we don't want to go above +1.5. Probably we will go above it. But just keep in mind, because if you want to evaluate, to assess the impact on the human health, you have to get clear what is the magnitude of change. And the temperature is relatively easy because it's not much varying. On the other hand, if you look at Northern America, you see that if a series, if a measure is highly variable, it means that you can get extremes. You are more likely to get extremes. You see that there are spikes in the blue line for Northern America, which means that during a given year, you can get an extremely high temperature and maybe 1 year later, an extremely low temperature. So variability is something that is concerning. Let's say concerning for the impact of extreme events. It's concerning. On the other hand, variability makes the natural environment more resilient because the natural environment gets used to it. Also the humans, the human health gets used to variability. So when there is a lot of variability, usually the human body and the natural environment becomes more resilient. And it's like a selection, a natural selection. And but on the other hand, variability is also dangerous for the extremes.
So can you say that the change in the blue graph and in the red graph are the same, but the variability?
Yes. Yes, correct. The change, if you average out over 30 years, you will see that variability disappears. When you take the average, variability is smoothed down. So it disappears, and you will see that the change is more or less the same, +1, +1.1. I mean, it's. I think that now there are graphs of global temperature. If you look in, let me see. If you look in Google, and there is a graph by NASA of global temperature, which is updated. Actually, I'm not sure they already put 2023, at least in part over it. Let me see, global temperature. Global temperature. Here it is. Here it is, okay. The last one is 2022. Okay, this is a graph of global temperature by NASA from 1880 to 2022. 2022 was not extremely cold. Let me see if I can. You may have heard this, that 2022 was not so bad. 2023, I think, is going to be maybe the warmest, because I'm not sure at the global level. We cannot speak for the global level. We have to wait for the measurements. And you see that it's very, very easy to find out these statistics. And so 0 is the long-term average. I have now a doubt about the previous graph. I think that 0 was probably the it was the starting point. So 0, maybe it was not the long-term average. In this one, I think it starts from 0. So I think 0 is like an average for the first 50 years in these graphs. And here, I think 0 is the long-term average, because if you look at this graph, I think that it's credible that 0 is long-term. So the change is between -0.2 to 0.9. So it's about +1.1. When you look for data, it is extremely important that you try to understand also the data sources and how the data were collected, because it's not easy to measure global temperature. We don't have a single thermometer. There are a lot of measurements which are spread over the land, not over the oceans, of course. And then they compute an average, a kind of weighted average, because of course, if in an area you have a high density of thermometers, you cannot take the average and give to the thermometers the same weight, because it turns out that you give more weight to the areas where you have a higher density. You understand what I mean? So basically, they find a weight to be assigned to each thermometer, and these weights need to change when if the density of the thermometers changes. So basically, a long time, in the first period here, we had few thermometers. In the second period, a lot of new thermometers. And therefore, there is a bit of uncertainty in this computation of global temperature. And you should understand these uncertainties, because for temperature is not a big issue. Because, I mean, okay, the uncertainty are there, but the uncertainties are there, but it's not a huge uncertainty. But for instance, about rainfall, there is a lot of uncertainty in the measurement of rainfall. So if you use this data, just beware of the so-called metadata, which should tell you how the data were recorded. Probably there is also an estimate of uncertainty. And this information is very important because if you look at the temperature measurements taken from satellites, the increase is a bit lower, not much lower, but like instead of 1.2 is 0.9, 0.8. Satellites are measuring the temperature not over the ground, but in the troposphere, which is the first layer of the atmosphere. So it's their measurement is distributed also over the oceans. So it's a different measure, and there are some differences. And keep in mind also that somewhere there is written in the northern hemisphere, the temperature increased more than in the southern hemisphere. It's not clear why. So, for instance, the North Pole is suffering from global warming more than the South Pole. So when you listen to the media, they often talk about problems for ice melting in Greenland, and they don't talk so much of Antarctica because it's less of a problem. And it's something that we still don't understand. And also get this message, understanding. Because of the variability, you know. So if you get a thermometer in Milan is representative also of temperature in Bologna, maybe. Rainfall measurement in Milan is absolutely not representative of the same rainfall in Bologna. And also, I tell you, the flood in the Romagna region that occurred in May was very local. So if you go out from this very restricted region, I mean, it was big flood, but it was very, very local. And in Bologna was not a problem. It was a storm, but not so bad. Okay, let me just look at the next slide and then I make a break and to solve the problem. Okay, now what you see on the screen now is the question that I asked you earlier. So there is a consensus that humans are responsible for climate change, and so why? Why are we mostly agreeing that humans play a relevant role in climate change? So you see here possible answers. So there is a consensus in the scientific community, which is indeed true. The media agree on the anthropogenic forcing of climate change. Climate models cannot explain current climate change unless anthropogenic forcing is considered, and the global warming is occurring with unprecedented pace, which was what we discussed earlier. So what is the correct answer? The correct answer, actually, it's this one. So it's not true that the pace is unprecedented. And indeed, temperature is increasing very sharply, but if we look at the geological records, we can find in the past periods where temperature changes were very rapid as well. So it's not a convincing explanation. The consensus of the media, of course, it's not a convincing explanation. And also the consensus in the scientific community is something that cannot be really claimed as a scientifically based support, because science shouldn't be about consensus, actually. And the history of science clearly shows that in the past, there was consensus over broad theories. But indeed, if we trust in models, if we believe that models can reproduce the dynamics of climate, and you apply models to reconstruct what happened in the past 30 years, If you don't introduce human emissions in these models, you cannot explain the rise in temperature. So I think it is a solid support. On the other hand, we should be aware of the fact that it's a support based on model assessments, not really based on observations that clearly tell us that there is a human component in it. And also, the way models account for human component is through the CO2 concentration. If you look at the changes in CO2 concentration in the far past through geological records, you see that we will see something about that, but I can show you a graph just now. 1 second, because I think it is instructive. Okay. It's another lecture that I have here, climate change and water cycle. Okay. And here it is. In this figure, you have a temperature variation starting from about 400,000 years ago, so 500,000. Temperature variations up to today, and then there is the CO2 concentration in the atmosphere in the past, and you see that they go hand to hand. They are really intimately coupled. And what is the reason? The reason is that when we get an increase of temperature, there is a corresponding increase in the release of CO2 from the oceans. The oceans are a huge CO2 sink. They can absorb CO2, but if the temperature of the water in the ocean increases, then the CO2 is released. So there is this natural link between CO2 concentration and oceans. Of course, this doesn't mean that the human component is not effective. On the other hand, keep in mind that we cannot quantify how much CO2 is released by the humans. We can get estimates which are not really rigorous, not really precise, and you can understand why. How can we really decipher what is the amount of CO2 concentration that is released by humans? With the human population that some of the continent, we don't know nothing. We don't know anything about what they are doing. So it is really not possible. And therefore, there is still uncertainty in that. So this is why there are vivid debates in the scientific community about the human component. On the other hand, it's clear that if you look at the past 30 years, this link is evident. If we look at the indicators of societal development, the great acceleration, the link is evident. Okay. Now, some numbers. They are, as I said, extremely important. So let's see. First of all, we already talked about global temperature. You can see there 1.3, okay, 1.2, 1.3. It depends on the location, as I said. And the temperature increased more in the northern hemisphere. Sea level, this is another big issue. And it is an interesting variable because sea level, like temperature, is not highly varying. Okay, we have tides, but it's not, the tides are varying really in the short term. It's not highly varying, and therefore it's an indicator that is interesting. And in fact, we very often listen from the media that it's a big concern, sea level rise. And sometimes we may get the feeling that the sea level rise is really a huge amount, okay? Now, let's look at the numbers then. The sea level rise, global sea level rise from 1880 to 2020 is about 21 centimeters of global average. And the sea level is not constant everywhere. It's changing because there are also, not just for tides, but because there are changes related to atmospheric pressure. Of course, if the atmospheric pressure increases in some areas, then you have a compression of the ocean. So looking at the global level, we need a lot of measurements, but the amount of the increase is about 21 centimeters. Of course, this is the average, and it doesn't mean that the extreme sea level caused by storms is of the same amount, because the extreme event is a combination of average sea level plus the storm, plus wind velocity, plus other changes. So indeed, it's possible that coastal flooding is increased more than the number of 20 centimeters may suggest, because actually, if you take an increase of 20 centimeters everywhere, it's not significant. It doesn't mean that a huge area is flooded. It's not really significant. But if you look at the extremes, this 20 centimeter may become something more important. On the other hand, it's important to be aware of this number, which is a combination of real sea level rise and the thermal expansion of the ocean. I mean, it's nevertheless a sea level rise, but what I mean to say is that it's not only ice melting, it's not only more water, it's also an expansion of the volume of water. And I mean, it's 20 centimeters. There are predictions for 2100. The more pessimistic ones from the IPCC, I will talk about IPCC just a little bit later. There are predictions from the IPCC that foresee an increase of sea level, which may reach plus 45 centimeters more from now to 2100, which, I mean, if it happens, it's quite significant. Global CO2 emissions have raised that these estimates are a really gross estimates, but the increase, I mean, the percentage increase, it's, I think it's a reliable indication. So they have raised from about 5 to about 35 billions of metric tons from 1940 to 2020, which means 7 times more. 7 times more, I think it's a good indication. 5 and 35, really it's a gross estimate. If you look at global CO2 emissions per capita, the increase is lower, of course, because also the human population is increased. And so per capita is about twice from 1940 to 2020. And the CO2 concentration in the atmosphere increased about 25% from 1980 to 2020. And this is a reliable measurement because we can measure the CO2 concentration in the atmosphere, and we cannot measure the human emissions. So when we say that there has been an increase of 25% of CO2 concentration, this is true. And we are getting closer and closer to the famous twice CO2 concentration, which means that we are almost at the double concentration of CO2 in the atmosphere with respect to the pre-industrial level. Global economic losses from weather catastrophes. This is a reliable estimate. They are about 300 billions of US dollars, steadily global economic losses every year, steadily increasing over time. Global population is increased from about 2.5 billions 1950 to about 8 billions today. And this is the result of the great acceleration. This is the result of the fact that we are reaching an improved use of our resources. So we have more food, we have more productivity, and this allows an increase of the population. But of course, this is bringing other problems, and as you know, which are related to migrations and related also to global health, because of course we know that when a population increases in number, then the health risks are increasing as well. Okay, negative impacts of climate change. Let's start talking about global warming. Global warming is a fact, first of all. There are a lot of debates in climate change. I mean, people are debating whether humans are responsible, most responsible for climate change. People are debating whether storms are increased, whether hurricanes are increased, the droughts are increased. There is no debate. It's a fact that global warming is there. So this is for sure something that we are observing. Glaciers don't lie. They speak clearly and they speak for the truth. They are retreating. Actually, their retreat started around 1750, but it's a huge retreat, which is more and more clear today. Okay, so, and I like the citation from National Geographic. Earth is warming up and humans are at least partially to blame. I think this is really objective. At least partially, I very much agree with this sentence. At least partially, maybe more than partially. Okay, the causes, effects, and complexity of global warming are important to understand so we can fight for the health of our planet. Indeed, we need to understand what is causing global warming. And let me make a clear example. If the increase in temperature is caused primarily by human emissions, it's clear what we have to do. For the future, for the long-term future, we have to reduce the human emissions. If you assume that the main cause is another thing, like increased solar activity, then of course there is nothing that you can do, that we can do for solar activity, and then our strategy should change. So understanding the causes is essential for solving the problem. And I think it's also essential for mitigating the impact on public health. Remember, we will talk about this. You have basically two categories of strategies to fight the impact, to mitigate the impact of climate change. And these two categories, we will talk about them. It's climate change mitigation on the one end and climate change adaptation on the other end. Mitigation means that we try to reduce climate change. Adaptation means that we try to adapt to it. It's a different strategy. Ideally, it's clear that we should apply both, but we don't have resources. We don't have resources, and therefore we have to give priorities. So is it priority adaptation or mitigation? So if you listen from a climate scientist, it's very likely that the climate scientist says that the priority is mitigation, because they are much concerned by climate change. They want to really reduce it. There is, to note, the time scale. The time scale of mitigation is long, and they say that. They say if we start now reducing CO2 emission, we will see the results in 2050, at least. The earliest in 2050. If you listen from an engineer, the engineer typically says that the problem is urgent and therefore we need to prioritize adaptation, because adaptation means an immediate solution to the problem, provided you have the resources. And therefore the engineer usually is more practical and say, okay, floods are occurring, droughts are occurring, we need to get protected against flood, because it's too long, the time scale of mitigation. And also the engineer, is very practical. So the engineer wants to be sure of the solution, and the engineer is not convinced typically by the positive effect that can be gained by reducing the CO2 emissions. This is a different interpretation that comes from a different background. Please.
Is it possible that the strategy or the strategy for adaptation kind of goes against mitigation? Like if you think of immediate solutions, they don't necessarily help the problem in the long run? Not
necessarily, but if you have limited resources, then it goes against mitigation, because if you don't have enough money, enough public money for sustaining both of them, if you give priority to adaptation, you don't prioritize mitigation. And this is also a political problem because, if you have governmental responsibilities, it's a difficult choice. And usually you cannot do both. But in principle, there is no competition between the two measures. I mean, of course, if you build a levee to get protected against a flood, you produce CO2 emissions, but they are not very relevant for building a levee. It's not a huge problem. And actually, I think there is no direct competition. The ideal solution, anyway, is what they call the no-regret solutions. So a solution that doesn't cause any regret in any case. Maybe it's not the final solution, but for instance, if you build a levee, okay, it's a long discourse, but it's a long discussion. But usually it's a no-regret solution because you solve a problem, a real problem that is a current problem. And this is also important from your perspective, from the perspective of public health. It's important because these interventions have a social cost. And in a situation where the public debt in Italy, for instance, is already huge, it's clear that if you deviate part of the economic resources on climate change mitigation adaptation, then the health system may suffer from that. So if you look currently at the discussion in the media for the financial plan of the government for the next year in Italy, some people say, put the money over public health and not over the Ponte, over the Stretto di Messina, so the bridge, the Messina Bridge or other resources. Indeed, this is a problem. So climate change is impacting public health and in any case is impacting the socioeconomic system in a different way depending on the local context. This is extremely important to understand. So in a given, climate change is impacting the poor more than the rich. There is no doubt on that. And Italy is in between, it's not a really rich country, but it's a country, it's not really a rich country, it's a country with a huge public debt. So indeed, there is the risk that climate change is impacting the Italian public health more than other countries which have more resources, so they can invest in public health, they can invest in climate change. And of course, investing in public health is a strategy for climate change adaptation, indeed. It is very interesting, this is a topical research issue today, to understand the conditions which lead to amplification of the impact of climate change. So think of public health. When it is more dangerous for people, an increase of temperature, if they don't have money for air conditioning, for instance, or if the hospitals don't have money for ensuring that people can be recovered efficiently against increasing temperature. It's extremely important to try to understand these conditions that lead to amplification. This is a new concept, climate change impact amplification. Why? When? So this is something really interesting. Okay, and keep in mind that global warming may also impact seasonality. Not only, I mean, you don't have to look only at annual statistics. It's also changes in seasonality are important. And I want to give you an example. We recently discovered that the river flow in the Po River has annual average, they are not decreasing. Or, yeah, a little bit, but not really concerning. So some people said, yeah, it's not much decreasing, so it's not a problem. But a more refined analysis showed that the annual average is okay, but the river flow of the Po River in July is much lower in the past 20 years with respect to the past century. And it's compensated by an increase of the river flow in March and April because of the anticipated snowmelt, because of the fact that it snows less. So this means that anticipated snow melt, it means that the snow melts in March, April over the Alps and not in July. In July, it's already melted, which means that you have a shift in seasonality and an increased risk of drought in the summer. Okay, global warming is not uniform. And this graph here shows to you that trend estimation should be performed over long periods, because if you look just from 1998 to 2012, it looks like global warming is stabilizing. Instead, if you look over the full period, you see that it's increasing over the whole time span. So when you estimate trend, you shouldn't focus on short periods, but in the long term. Okay, now, weather extremes. Temperature is one thing, it's relatively easier. When you talk about precipitation, there is no clear indication of whether floods are increasing in frequency and intensity due to climate change. It looks like they are clearly increasing. If you look at the media, they say that they are increasing. The damages from floods are increasing, indeed. The damages are increasing, but damages are increasing because it is increased the value of the area that are flooded. So in the terminology of the engineers, we say that exposure is increased. I will give you more details later, but basically just keep in mind that exposure is the economic value which is exposed to the risk. So if the land is a virgin land, okay, there is a damage from flooding, but it's a damage to environment which is also easy to recover from. If a land is urbanized with a lot of industries, with a lot of production there, the economic value is increased. So we say exposure is increased, which means that the damage, if a flood comes, is increased a lot. So this is why, if you look at the statistics of global statistics of damages caused by natural disasters, you see an increase of the damages caused by floods and droughts. But if you look at the frequency at which they are occurring, there is not a clear increase. And the situation is, if possible, more complicated than that, because indeed what we are sure about is that huge floods are not increased, they are decreased. Think of the Po River. The Po River had a huge flood in 1951, a huge flood in 1994, a huge flood in 2000, and then in the past 23 years, nothing. And it's not only the Po River. If you look at the statistics for huge floods over Europe, they are decreased. What it seems increased is the frequency of the small-scale floods. Small scale means not extended in space and not extended in time. Keep in mind that the spatial extension of a flood and the temporal extension, the duration, they are related. If you have a big flood, for instance, the Po River flood, it lasts for a long time. You have water that comes out for days. If you have a small flood, like the Romagna flood, you have water that comes out for a few hours. I mean, it's still very impactful, but just keep in mind this tight relationship between the spatial and temporal scale. So try to understand these processes, because you will be the one that has to take care of people that are flooded. So try to understand these processes. So the huge floods, their frequency doesn't seem to be increased. The small floods, indeed, it looks like the situation is not clear, and they may be increased. I just want to tell you another detail, which I think it's very interesting, and in order to understand these processes. Small floods are caused by short duration rainfall. Think of it. Like the flood that occurred in the Romagna region lasted 12 hours. the flood that occurred in the Marche region last year lasted like half an hour. So small floods are caused by very short rainfall, and there is a physical explanation for that. The huge floods are caused by rainfall that may last for like 2 weeks. If we get a flood over the Po River, it means that it rained for at least 1 week. And as I said, there is a physical explanation, and I think it may be interesting to try to provide it with very simple means. For the Po River, water takes a long time before it is collected, before it gets to the main river, and before it gets to downstream. So basically, if you have rain over the Piedmont region, rain over the Veneto region, rain over the Lombardia, before this rain gets together, it takes time. So if meanwhile it stops raining, then the flood doesn't occur. In order to cause a flood over the Po River, it needs to rain at least for the time it takes rainfall to get together into the lowlands. So if it takes 1 week to the water that falls in Valle d'Aosta to get to Ferrara, we need a rainfall in order to cause a flood that lasts for 1 week. Because in this way, it means that you are collecting rainfall over this big area, and at the end of the story, at the end of the week, you have the full rainfall for 1 week over the whole area that gets together, and it may cause a flood. So this understanding this functioning of the environment is essential in order to make a prediction and in order to get prepared. So what they do along the Po River, typically it starts raining, there is a rainfall weather prediction that says it will rain for 1 week. And then they get alerted and see what happened, and they monitor the level along the rivers in the various regions to see if indeed the rainfall is lasting, and they measure rainfall, and they have time to get prepared. After 4 days, if it continues to rain, and they start to alert people, and this is the way they work. And this is, in a way, they have time. On the other hand, the area to be evacuated is much larger, so also the procedures for making sure that people are not injured, the procedures for, take time. And therefore, it's a situation that is completely different from a small flood. A small flood, basically, they rely on weather prediction, but weather prediction, there is more uncertainty. So what is the reason why floods along the Po River don't get people by surprise? Usually people know 1 day in advance that they will be flooded. There are people that don't want to leave their homes, people that decide to leave. But when you have a small-scale flood, people usually are taken by surprise. Like they are driving and they don't suspect at all that a flood is coming. And also there are some situations that are really difficult to predict. I want to give you an example. In the flood in Germany, 2021, it was a huge flood. It was in summer, you may remember, and the media that were reporting this tragedy, I think 130 people died. And in the hospitals, they had a breakout of the power. So because the flood was so huge that the public power system, the power network failed, but also the generators inside the hospitals failed, and they had to evacuate the patients by hands without elevators. And indeed, it was something that they didn't expect because it was so fast. They couldn't get prepared, and it was something really expected. And this typically happens when the scale is small.
How do we, this past summer here in Milan, we had two,
Yeah.
I would call them not maybe cyclones, but something similar, like strong
Yeah.
winds.
Yeah.
Like buildings falling down.
Yeah.
Like, even my grandparents who lived in Milan their whole lives said they'd never seen anything like it.
Yeah. You know,
Like, are those the kind of extreme weather?
yes, because the physics of climate change basically supports the interpretation that the short term extremes may increase, the short term in time and space. And so the type of phenomena that evolve in 5 minutes or 10 minutes or half an hour, indeed, the physics supports the interpretation that they may have been increased. While the physics doesn't provide so extended support, so consistent support to the fact that longer term extremes are increased. So indeed, global warming, it is likely that has generated an increase of the energy in the atmosphere and an increased content of water. So it may generate indeed more thunderstorms and more cyclones, like cyclones type of extremes. So indeed, the physics is supportive of that. The data, it is tricky because this is what this slide says. To observe these phenomena, it's very difficult. It's difficult because they evolve so quickly that the measurements typically are affected by a large uncertainty. So we don't have really data showing that the frequency of these events is increased. We don't have data supporting this, but the physics is supporting that. So indeed, I tend to believe, even if I don't have a high confidence on models, usually I am more confident on data, and this is typical of the engineer. And but in this case, I think if you look at the data of short-term extremes, really you don't see a clear trend. But I tend to say that it is likely that there is an increase of that. The memory of people, keep in mind that the memory of people is about 50, 60 years long. It's not a long time span. So, I mean, the fact that people say I didn't see anything like that, it's not very significant. And because the memory is not so long. I mean, extremes, but typically they are defined for an average frequency of 1 every 100 years. So maybe that 100 years ago in Milan there was something similar, but not measured, and maybe the reports are not so. But on the other hand, I think what happens this summer clearly shows that we need adaptation. We need to get protected. Also in the Romagna region, it's clear. I mean, what happened, it's clear. It may happen again. So we need to get protected. But the solution is not simple. Okay, you see here, several studies confirms a slight increase of extremes depending on location and type of extremes. Okay, now let's move forward. Droughts. This is another negative impact, and droughts are extremely complicated because it's a long-term process, very extended in space, and it's extremely complicated because they are caused by a persistence of low rainfall. So at the beginning, typically there is a low rainfall, not always. It can be also anticipated slower, but typically the droughts, which mean water shortages, are caused by low rainfall. And it's not clear whether under climate change, the frequency of droughts is increased or not. And they are so rare that it's not really clear. And but droughts are really something very relevant, and they cause a lot of diseases, a lot of impacts on the food production. The socioeconomic impact is relevant, and also the impact on the environment is very relevant. I mean, it is really a big problem, and we can adapt to them, but on the other hand, adaptation requires water storage. Water storage has an environmental impact because it means dams, it means reservoirs, it means depletion of river flow downstream. So it is, and also it's a solution that is not permanent because dams don't have, and they have a duration. I mean, they don't last forever because they get filled up by sediments and their efficiency decreases. but indeed droughts are a huge issue. In my website, I go a little bit, just a second over it. In my website, there is a link here on the right, on the left, and it's an ebook, A Travel Through Time to Explore Past and Future Mega Droughts. And there is description is a narrative on mega droughts that hit humanity starting from 1,000 years ago. So 1,000 years ago, mega drought in Australia, and these were droughts really that lasted for like 100 years. It's something we don't have an explanation for this. Why? I mean, it's something that happens once every 500 years, and precipitation decreases for 50 years, or like in Australia from 2000 to 2010. I mean, 10 years of drought. They built a lot of desalination plants because they thought that forever they had this problem. And now the desalination plants are abandoned, are left there because they don't need them anymore. It's really something. And then 10 years ago, multi-year drought in UK and Italy. And 8 years ago, this is the Dust Bowl. This is a fascinating story. There is a Wikipedia page, and which explained this drought that caused the displacement of thousands of people in the United States. It lasted for 5 years. And it is really interesting. And then 20 years ago, droughts in Australia, California, South Africa, and millennium drought. And today, there is, I think, today, the Po River drought. I have to update this because I made a research on the drought of the Po River of 2022. The assessment that brought us to conclude that it was caused by snowmelt anticipation. There is a link somewhere. But this is an interesting reading if you have some time, and it's really easy. It's not really, I mean, maybe too much details for your purpose, but droughts are really an interesting story.
Like, what if for example, so I lived in South Africa for a while, and every house of like anyone that's rich enough has these big cisterne, say these big like tanks of water. So that's, I guess, an adaptation technique, but it doesn't solve any problem in the long term.
No, because the history of South Africa is interesting. You called it cistern, I think. Also cistern. Yeah, it's, they are usually called in engineering tanks, but because I think cisterns are larger.
I think cisterns are like, for example, in the Ottoman Empire, they were underground areas, and
Yeah.
maybe what you mean is like a water.
No, these are like big, like massive water bottles, like in the garden.
Yeah.
They're not like an area.
Yeah. You know, South Africa experienced a huge drought in 2014 to 2017. And they got close to the day zero. Day zero is called the day where you open the tap and you get no drop of water. And this is a nightmare for any water manager. So they are really concerned by the day zero. And they got very close. And the reason was that they are relying for water supply mainly on reservoirs. So it's a unique source. And this is a basic rule for ensuring resilience. You should have several sources of whatever good is necessary for your life. You should have several sources. Think of energy. We were dependent on Russia and we got in trouble. Now we are dependent on Algeria, and it seems that we are getting in trouble again. So basically, when you have something that is necessary for public health, for the survival of the society, you should have several sources. When it is possible. South Africa really had a lot of dams, but only surface water. And they actually built an additional storage just a couple of years before the drought. So, and they had quite a rainy period for like 10 years. So they were quite relaxed. and they were not really resilient. They didn't realize that they were not really resilient. There was the drought that brought them close to base zero. And then they resorted that they needed to make sure that they had an additional reserve. And then they promoted the use of these tanks, which primarily are used for irrigating the garden for, let's say, not for human use, but for any other use, which may be flushing the toilet, irrigating the garden. I mean, separating the distribution of water inside the house is a challenge. So for a new house, it can be done, but for an existing house, it's a challenge. But they, indeed, in several countries that experienced droughts, they tried to adapt in this way, using tanks. And the experience in Australia is particularly significant because they have already more than 10 years of experience. And the main problem with these tanks is to keep them clean, because after a while, you have a deterioration of the water, and even if you don't use it for human use, still if the water has a bad smelling, has colors, it's not nice, because if you use it for flushing the toilet, I mean the pipes inside the house get damaged, and also the hygienic conditions get. So this is really a kind of a problem. But in Bologna, they made an experiment. They financed people in order to promote the use of these tanks. But it was just a very small experiment, only few families. But I think this is a good idea. And I thought of it also in my house. It is a bit expensive because you need quite a huge volume. So you have to go in the excavator and put it in the underground, because otherwise it's a bit over the roof, is a bit of a problem. Even if over the roof it would be better, but it gets very hot. And the quality of water, when with increasing temperature, decreases. One indicator of the water quality standards. But it is indeed a solution. This is dedicated to hurricanes, and you see how the tropical cyclone is structured. And this is what happened in Milan and in Milan last summer. And here there is basically what I said before. Globally, there is low confidence in attribution of changes in tropical cyclone activity to human influence. And this is the IPCC. The IPCC, as I said, I will introduce it later, but it's the international organization. It's the International Intergovernmental Panel on Climate Change. It's a panel formed by hundreds of selected experts, high-level experts, which are very conservative. So they tend to assume that the human impact is the main reason of climate change, the human emissions. And therefore, if their conclusion is that there is low confidence in attribution of changes in tropical cyclone activity to human influence, it means that indeed there is no certainty on that. As I said, and they also say this is due to insufficient observational evidence, lack of physical understanding of the links between anthropogenic drivers of climate and tropical cyclone activity, and the low level of agreement between studies. So, I mean, it's not easy, but I would say that it is reasonable to assume that probably with these high temperatures, these phenomena become more likely.
I mean, it's not exactly close to a speed.
Not necessarily. I'm not an expert. I'm not a climate scientist, but I think that if you have, they are caused by a lot of energy in the atmosphere, a lot of humidity, which causes movement of masses of, like in this movement of masses of air. This kind of movement, you basically you have a raise of a volume of air, a warm rising air, because when it's warm, it goes up. And then basically it generates these sudden winds. I don't think it is related to only to oceans because they can also move, you know, these perturbations. I'm thinking of New Orleans. It was an hurricane, and New Orleans is close to the ocean. But given that I'm not an expert, let's look at Google or Wikipedia. Let's look at Wikipedia. Okay. Not really. Let's see Wikipedia. Hurricanes. No, Carolina. No. Okay. Weather. Okay. Seasonal course with no wind. Let's see. This is Atlantic tropical cyclone. A tropical cyclone is a rapidly rotating storm system. A low pressure center. Referred to different name. Hurricane, typhoon. Okay, tropical storm. Yeah. Okay. I think that depending on the name, different names may indicate different context. So hurricane may be that it's related to the sea, but in any case, the tropical cyclone not. Okay, it's not directly related. Here, actually, we are talking about hurricanes, but I think that what happened in Milan is better referred to as a tropical cyclone. Okay. Okay, let's move forward. Sea level rise. Okay, I think we already discussed it. So let's look at the negative, and then I make another break. Effects on health, and it may generate injuries related to coastal flooding. It may generate stress. It may generate salination of coastal waters and destruction of coastal ecosystems. I would say that I don't have anything more to say about this, but let me just show you before the break another link, which I think is an interesting reading for you. And Broad Street Pump, Wikipedia. And here. No, I want to see it in English.
You can click on the yellow box if you change.
Yeah, great. Thank you very much. Look at this. And it's an history or a report on the cholera outbreak that occurred in London and in several countries of Europe in 1854. And it's related to the Broad Street pump. This is a replica of the Broad Street pump. Do you know the story of this cholera outbreak? And basically, people didn't know at that time what was the cause of cholera. They thought that it was spreading on air. This was one of the interpretations. They didn't realize up to 1854 that it was spread by water, by dirty water. And the mechanism is very simple. With the increase of the cities, the hygiene of the groundwater was decreasing because the fecal pollution by increasing number of people reached the groundwater bodies. And therefore, they started drinking the water which was infected. But people started dying and they didn't know what was the cause. So there was a medical doctor that started with a brilliant idea. He mapped the cases, the deaths of people. And he realized that around this Broad Street pump, which was a public source of water, they didn't have water in the houses. People were going there to take the water from the pump. He realized that close to the pump, there were several cases. And he then elaborated the hypothesis that the cholera was spread by water. It was a great discovery. And keep in mind that this occurred also in Bologna and other cities, in Paris. And in Bologna, what they did was that the water was tasting so badly but they didn't realize that this was the reason of the cholera. Because, you know, when you have a general consensus in one direction, in one interpretation, it is really difficult for people who go against the stream to get believed by the system. So basically, they were so reluctant. They didn't realize that, even if the water tasted very badly. And what happened in Bologna was that people started mixing the water with the wine to make the taste better, but still the wine didn't kill the bacteria, didn't solve the problem. So people continued to die while drinking wine. And there is a say that the wine industry promoted this solution because they wanted also to sell the wine, but they didn't realize it. And what happened here in London, this medical doctor, I don't remember the name, I think it was just a sec. Yeah. And John Snow, this guy also noticed that around a monastery, the monks were not dying. So they were completely healthy. And he didn't understand why, so he visited these monks and realized that they were drinking only beer. And this was the reason. And the beer, after fermentation, basically they didn't get infected. This is really a nice story. And it is also stimulating a reflection. You know, these people were continuing to die without realizing that the explanation was so simple. And my reflection is maybe that in 100 years from now, because not long time passed since then, in 100 years from now, people will discover why we are dying from cancer, and the solution may be very simple, something that we don't really see, even if it's very simple. And this is, I mean, can you think of how many people died for this? And I mean, this means that sometimes with very simple observations, a mapping of the cases, he could solve the problem. And since then, people started to look for groundwater in the deep underground. This is why now we don't take groundwater from 10 meters underground for human use. We go much deeper. And this is the reason. Okay. I go to the next one, and then let's make another breath. Really out in the hospital. Yeah. Yeah. Okay, I see. Okay, so let's talk now about the benefits of climate change, because you know, when people talk about climate change, there is a pessimistic view of it, and also, and for this reason, they often, the media especially, they focus on the negative side and don't focus on the sides that are not so negative. I think it is important to have a complete overview. Like, for instance, very often when they evaluate the impact of climate change on the health of people in 2050, so in 30 years from now, there has been a paper published in Nature 1 month ago. I think it was very interesting. They noticed that they don't take into account that public health will improve in the next 30 years. And on its own, I mean, and also the life expectation of people will improve. And therefore, this is balancing, in a way, the negative impact of a society that is becoming, for other reasons, less healthy. So for sure, society is becoming less healthy for increasing pollution, for some living conditions that are going to deteriorate. But it's also true that these deteriorations are sometimes due to the fact that we improve our lifestyle. So, I mean, if people basically today turn on air conditioning, of course, they cause an increase of emissions, and therefore people are evaluating the impact of air conditioning in terms of global warming, and then the negative impact of air conditioning on the health of people. But careful assessment should take into account what are the positive impacts also, because sometimes you may tolerate a worsening of some conditions, like we talk about pollution of rivers, you may tolerate a moderate pollution if this brings to improving our other living conditions. For instance, if you store water in a reservoir, into a dam, in order to mitigate the risk of droughts, you decrease the water flow downstream and therefore increase pollution, because for the same amount of pollutants, for the same mass of pollutants, you have less dilution and therefore an increased concentration of pollutants. And so this is a damage on one side. On the other hand, the fact that you store fresh water and clean water upstream implies that you can use it in case of shortage, and therefore is bringing a positive effect. And there is a bias indeed in the evaluation of climate change, of the effect of climate change, which brings us to focus on the negative aspects. On the other hand, it's also important to have clear the benefits. So here there is a short list. Cold waves will decrease in intensity and therefore in frequency, and therefore the negative impact of cold waves will be mitigated. Decreased avalanche risk in some regions, in mountains, and also farmers in some regions may benefit from a longer growing season and therefore an increased productivity. And not only farmers benefit from them, but it's also the community, the overall community that takes benefit from an improved food production. And also tourism may benefit from a longer season, but not skiing. And by the way, in the Alps, there is a lot of concern about the future of the skiing season, of course. And shipping commerce may benefit from the possible opening of the Northwest Passage. I think you know the Northwest Passage, which is very often blocked by ice. When it's open, it allows shorter travel in order for commerce, and therefore is bringing benefit. And also North regions may benefit from an expansion of agriculture. Here there is a spelling error. So, I mean, there are benefits, and these are to be considered because the overall development and the overall concept of sustainability must be based over a cost-benefit analysis. It's complicated, of course, because you need to study the system, the socio-economic environmental system in all of its complexity. On the other hand, if we want to make a careful assessment, also in terms of public health, this is a necessary step. Okay, now the IPCC. The IPCC is the Intergovernmental Panel on Climate Change. As I said, it's a panel of hundreds of experts, which has been established, I think, in 2003. And they are periodically producing a publication called Assessment Reports. Let me just show you. First of all, IPCC. One second, IPCC. IPCC, here is the web page, and just 1 second, I close here. And here there are the reports. The reports are produced periodically. The last one is the 6th, has been released a few months ago. It's not yet complete. There are some parts of the report that are still presented in form of draft. And then there are all the previous reports here. Of course, they are complete. AR6, let's see, AR5 somewhere, AR5. From AR1 to AR6, you have a complete list of reports. These reports cover several aspects related to climate change, including public health. AR6 so far didn't dedicate a longer part of it to public health. AR5, yes. And let me see AR5 here, synthesis report. And here is the report. And if you look at the synthesis report, it's maybe we can download it quickly. There is a section on public health, and that should be somewhere here. Observe change, climate change, risk and impact. And here I think there must be something related to public health, the water cycle, air temperature. I am sure. Okay, now I don't find it very quickly. But in any case, if you look for climate change, public health, you get to you get straight to the report of the IPCC. Basically, what I want to highlight to you is that these reports are an excellent reference and an excellent reference for understanding the magnitude of climate change, understanding the projections, so what we are expecting for the futures in terms of climate change, and also for assessing the impact on public health. I have several figures in what follows in the next lectures maybe, which are taken from the AR5 assessment report, which clarifies what are the connections between climate change, health, human health, etc., health, and also socioeconomics impacts, etc. They are, as I said, an interesting reference. Keep just into account that there is a part of the scientific community that thinks that IPCC is a little bit biased towards a very precautionary attitude, very conservative attitude. Just keep it in mind. I don't think this is relevant, but climate change is a controversial topic. Also, we will discuss some more about the main controversies. And so there is a part of the scientific community that thinks that IPCC may be a little bit too conservative, like not considering the full benefits of climate change, or even in predictions, maybe that the predictions, the projections, as they call them, are a little bit too pessimistic. And this is something that you just have to keep in mind because it's a mainstream interpretation. I mean, it is really well supported. I mean, the scientific community is about 80% in favor of everything here. And so, I mean, it's real mainstream, it's reliable, maybe a little bit too conservative. And but the reference is really great. I must say, when I try to get prepared at my best for these lectures, I didn't find much on public health. I think I will show you what I found. I think they are basically well-known things like cold wave, hot waves, so elder people, but still, I think it is interesting. Okay, now let me focus a little bit on my core field, water-related disasters. And as I said at the beginning of this lecture, I really don't understand why climate change is considered a big issue and water security not, or water-related disaster not. I think the real reason is that water problems are local problems usually, not usually, typically. They are typically local problems. And the reason why they are local problems is that water cannot be moved. This is an important feature to take into account. While we can import gas, we can import food, other goods, we cannot import water because water is very heavy and it involves very large volumes. So we cannot build a pipe bringing water from Sweden to the south of Europe. This is impossible. It's not practical. And it would solve a lot of problems because in the Earth system, there is enough water for everybody, enough fresh water, I mean, and also even if the human population increased a lot, like twice the current values, there would be anyway enough fresh water for everybody. I mean, fresh water, not to speak about salt water. You know that fresh water, salt water is 97% of the total water in the Earth system, 97%. The remaining 3%, 1% is fresh water that can be used by humans, but still this 1% is enough. And if it was not enough, there would be desalination. Now, not very practical, but in the future it will become for sure practical. So I mean, water is enough. The problem is the distribution. The distribution is uneven, both in time and space. So sometimes in the same country, we have too much water in winter and too few water in summer. And in some countries, we have a lot of water, more than needed, like in north of Europe, and in other countries, south of Europe, we don't have enough water. But again, we cannot build a pipe bringing water from Sweden to the sides of Europe. Water cannot be moved. And this is why water is considered to be essentially a local problem, a local responsibility of administration, not a global responsibility. Now the perspective is changing a little bit, because with globalization, people realize that most of the water that we use is used for producing food. 80% of the water, 70% at the global level, 80% of the water in Italy is used for irrigation, for agriculture. And therefore, this means that if we want to solve water problems, we have to focus on water for food. And this is why the water-food nexus is so popular, so important. And now it became the water-food-energy nexus is important. Now, if you can't move water, you can move the food. So with globalization, people realize, the communities, the international community realize that where you don't have enough water for producing food, you can solve the problem by importing food. Of course, provided the socioeconomic system supports that. So globalization is providing a way out, at least up to the economic crisis of 2007-8, because after that economic crisis, you may know that the socioeconomic system underwent a shock which is not completely resolved, because and also with the pandemics, the shocks was reinforced, because the international socioeconomic system, the international commerce, is now suffering from inflation. Inflation is due probably to the pandemics and maybe to the international crisis of Russia. But this problem was introduced after the economic crisis of 2007-8, which caused an increase of the public debt of states. So, I mean, globalization is offering a solution if we are able to sustain the global circulation of goods and resources. But water cannot be moved. So basically, I think this is the reason why it's considered to be a local responsibility, not a responsibility of the superpowers, of the global consortium of states. So this is why water usually is not discussed at the G20 or other international symposium, while climate it is, because climate indeed is a global problem. And the responsibility, climate change is not confined to a country. A water problem, yes, is confined to a country or a region. Climate change is exported. And this is why probably there is more attention. But actually, if you look at the impact of climate change, mainly it is taking place through water. What you see here is a picture of the cost of 2022 climate-related disasters. And you can see that hurricanes, this is a single hurricane, Hurricane Ian, which was the most costly disaster of 2022. And then we have the drought in Europe, the floods in China, etc., etc. So, I mean, if you look at these disasters, okay, one can say that hurricane is not really water-related, but the drought is, the flood is, drought, floods, storm, water-related, and drought, floods, hurricane. So, I mean, most of them are through water. And Now, here there is the question, in your opinion, is the frequency of floods increased at the global level? And yes, it is increased for land use change, because this is another possibility. Land use change is increasing the risk of flood. Yes, it is increased after climate change. No, it's not increased. Yes, it is increased, but it is still not clear what the drivers are and what is their relative contributions to frequency raising, I would say this, okay? And flood frequency is increasing for the combined effect of different anthropogenic impacts. Climate change and land use change are the most important drivers. Actually, we already discussed flood frequency, and we already made the difference between huge floods and small ones. Okay. Uncertainty. We are heading toward the end of this lecture, and let me introduce some food for thought. First of all, uncertainty. And what is uncertainty? Uncertainty is an essential component of science. If science was not affected by uncertainty, there wouldn't be scientific research. And we make research because we are uncertain on the dynamics of certain processes, and we try to limit uncertainty. But there is something more that we have to say. Most environmental processes, include climate processes, are chaotic. What does it mean, chaotic? You may remember the say by Lawrence of the butterfly, and it's written on the screen. A butterfly's wings may ultimately alter the path of a tornado, or delay, accelerate, or even prevent the occurrence of a tornado in another location. The butterfly does not directly create the tornado, but the flap of the butterfly's wings can cause the tornado. So what does it mean that a butterfly can cause a tornado? It means, and precisely it was said by Lawrence, that a butterfly wing in Japan may cause a tornado in New York. What is the meaning? The meaning is really interesting. When you have a chaotic process, if you make a small change in the initial condition of the process, so if you start from a temperature, for instance, of the atmosphere that is 35.1 instead of 35.0, this small, tiny, negligible change in the initial condition may cause a huge difference in the final outcome, because it gets routed through a process of amplification, of expansion. This means chaotic. It means that the process is simply unpredictable, because when you measure the initial condition, even a small mistake generates a completely different outcome. This is chaos. And most of the climate processes are chaotic. This means that there is an inherent uncertainty, which is not due to the fact that we have a limited knowledge. Part of uncertainty is related to limited knowledge. And this is called, by some authors, epistemic uncertainty, which means that it can be removed if you improve your understanding. Epistemic, it's a term that I don't like, because already uncertainty is a term that is not really exciting. If you call it epistemic uncertainty, is really bringing your enthusiasm to a very low level, because it's a term that is very critical. Basically, it's important, the concept that I want to convey to you is that you can split uncertainty in two parts. There is a part that can be eliminated by improving our understanding, but there is a part in some of the processes that cannot be eliminated, is inherent. I'm really interested in getting, maybe if we will have time, discussion with you about the notion of uncertainty in medicine, because I think there are several analogies. I think when you make a diagnosis over a patient, I think that there is uncertainty, and maybe the uncertainty can be in part removed, but I think there is an inherent part of it, something that it really makes the prediction unpredictable, at least for a part of it. And it's important to keep into account this feature of climate. The predictability of climate is limited. And especially in the long term, you know, there is a proverb which says, making prediction is a difficult task, especially in the long term. This is indeed true with climate. So this is important because actually we make predictions of climate. And climate scientists call them projections, not predictions, precisely because they don't want to call them predictions. They say that these projections are meaningful in statistical terms, not in a day-to-day prediction. In fact, we know that the weather forecasting is reliable today. They improved a lot, but it's reliable for 1 week. And then after 1 week, reliability decreases. So in climate, we make predictions up to 2100. So it's clear that cannot be a day-to-day prediction, but must be at least a prediction over statistics computed over a very long term. So this is particularly important. So just keep in mind that our predictions with climate models are uncertain, and keep in mind that this is a very sensitive topic. When you talk about uncertainty in climate, be careful of your audience because it's very sensitive. I mean, if you there is a discussion which I think it's interesting in the scientific community. Even in hydrology, in my field, there are some scientists which are convinced that you shouldn't communicate uncertainty to the public. Because in this way, if you communicate uncertainty, you undermine the public trust in science. And I think a similar reasoning may be extended to medicine. Is your uncertainty as a medical doctor to be communicated to the patients or not? Or in what way? We have the same question. Should we communicate uncertainty or not? So there are different interpretations. Some people say only to decision makers. So decision makers need to know uncertainty. I am an engineer, and my opinion is, look, an engineer cannot work without an estimate of uncertainty. It's impossible. Any design project has to be based on on an estimate of uncertainty. And without an estimate of uncertainty, I can't do anything. And also, I am obliged by law to take into account uncertainty. On the other hand, I fully understand that with the public, if you say, okay, climate is changing for 2100 this is our prediction, but I don't trust it. So it's not a nice message. The way you communicate it is extremely important. And I think this is really an interesting discussion. Just keep in mind that, it is a topical issue, and it is not very popular for the reasons that I mentioned to you. Now, here there is a question. What of the following statements best describe your idea of uncertainty in science? Uncertainty is caused by limited knowledge, which in turn implies that predicting models are wrong. Uncertainty can be eliminated by improving scientific knowledge. Uncertainty is caused by imprecise information. Uncertainty means limited predictability. It's not necessarily due to lack of knowledge. Okay, you may say that several of these statements are maybe acceptable, but I would say that the best one is the last. Uncertainty is limited predictability. Okay, I am almost there. I take 5 more of your minutes in order to discuss a couple of few things. We will talk about science or climate change. And
that's predictions, we call them projections, but are there also climate predictions for, I don't know, flood and climate projections for longer periods?
yeah, basically now the climate models are evolving in a way, they call them Earth system models. So they are trying to predict not only climate, but also after rainfall, the movement of water over the land, and therefore floods. They are evolving. The problem, and in the past, the way floods were predicted for the future was by coupling a climate model with a hydrological model. So you run a climate model, get rainfall, and then you take rainfall and use rainfall as an input to an hydrological model. So in the past, indeed, we used this combination of models, and now they are trying to combine them in the same unique model. And the problem, again, is uncertainty. So when you use a cascade of models or an integrated model, which means a model with a higher complexity, uncertainty is amplified. Because you have the climate model with uncertainty, the hydrological model has uncertainty. So if you use them in cascade, it's amplified, but it is amplified also if you integrate them, because the more the complexity and the higher the potential uncertainty. So there is a way to make flood predictions. There are several ways. I am convinced that still the cascade of models is the most reliable approach up to now. But I am discussing this issue with climate scientists, and they say we are already doing that with our models, but actually they have a resolution that is too coarse. So I still think that the best way is to combine them. I hope I answered your questions. Okay, very good. So this slide, I think we don't have to comment very much, but let's focus on the definition of science. Science is a systematic endeavor that builds and organizes knowledge in the form of testable explanation and prediction about the universe. The term testable is essential. Science is objective, and its conclusions should be supported by testing and validation. Why I am emphasizing this definition? Because consensus is not a test. So just keep in mind that science should be based on tests which may falsify a theory or confirm a theory, and validation, which is a synonym of test. So the test cannot be the consensus of the mainstream. And this is relevant because in the case of climate change, instead, very often you see people are relying on consensus. It's a bit dangerous, in my opinion. In the past, there was the consensus that there were witches and they, what they did, because there was a consensus that some bad luck was brought by witches. So it's a bit, and Galileo was forced to excuse in front of the Pope because of his theory, which then turned out to be correct. And now Pope Francis excused, after 500 years, excused for this behavior of the church of the previous Pope with respect to Galileo. Okay. Hydrology, of course, I am an hydrologist, so I'm convinced it's the most related science to climate. And okay. And here I close my lecture with these questions, which we will explore during the next 9 hours. So basic questions: what is the magnitude of climate change? We already got some hints, some first assessment. How climate change is affecting water, socioeconomics, and public health. What are the causes of climate change? We already started the discussion. How we can generate future climate scenarios. We will talk about models and uncertainty of climate predictions. Here, I suggest a reading. I am subserving. This is my last paper, and it's the analysis of the Po River drought of 2022. It's public domain, and you have the link in my website. You can download this presentation. There is the link if you want to have a read. I think it is an easy reading. And but of course, maybe a little bit unusual for you, but I don't think it is difficult. Here is a figure which shows that the river flow in the big decline is for the river flow in July. If you look at the river flow in May, June, July, you see that there is not a big decline. And we put together a very long series from 1807 to 2022. And so this was our main conclusion. And if you look at April, May, June, July, you see there is no big decline. But if you look at July, indeed, there is a big decline. Okay, the final page is just a summary of the questions and that's it. I think we can stop here. Do you have any question? And do you have any suggestion for me? Was okay. It was complexity is fine, not too easy, not too tough. Okay, good. Thank you very much. Okay, we will see each other November 2nd, and it is in the middle of what we call a bridge in Italy, but I'll be here. Yeah, you will have class on November 2nd. Okay, okay. That's great.
I think they should have made Monday and Tuesday.
They should have done what?
If Monday and Tuesday were also.
That's